Hello, everyone. Welcome to another live stream. Today, we're going to be talking about preparing to do our PID control. No, I did not say we're actually doing the PID control. And I originally was going to do a long PID video one. That's probably going to be like 4 hours. And I was like, yeah, I don't know if I have the stamina for 4 hours. Don't know if you have the stamina to listen to me for 4 hours. But what I notice most people, when they're like, yeah, I need to do a PID, they immediately drag the PID instruction down. It's like, that's got to be the first thing. I'm like, nah, there's a little more that we've got to work on before we do that. Now, let's talk a little bit of where we're actually at in, I guess, the grand scheme of, oops, let me go ahead and close that out. We'll go ahead and start fresh of what we're doing. So if you go, oops, if I was more prepared, there we go. If you go to courses.twcontrols.com, and then go into the connected components workbench training, and I'm just going to hit the resume course. Then hopefully by the time you watch this has a better title. In fact, somebody described to me what this is in the chat, because yeah, I'm trying to figure this out. But originally this was some short videos for some schools that really wanted to spend a few weeks on PLC training, but didn't want to go fully in depth. And so, oh, isn't that cute? Amber and I are so cute. And yeah, there's the junior board director's hat. I just totally squirreled off there. But so even here, I start saying these are now, this is turning into a deep dive into PLC programming. And that is no longer the fast track. Now we are just doing some long burn lessons. So our first one was downloading the software, connecting components workbench, connecting and hitting our basic instructions that you run into. The next one was on timers as encounters. And then we had PLC programming sequencing methods. And then we did our analog outputs. And then we have PLC troubleshooting. And so the next one that really I think that a lot of you want to cover is the PID. And what I want to do first is prepare our control variable and our process variable. And so the process variable is that thing out there that we want to be at a certain spot. So, I mean, if it's an oven, maybe the oven's set at 350. So we're going to measure the temperature. That part we're measuring is the process variable. And then we're going to use something to try to get it there. And that's the control variable. Now, in the case of our trainer for this, we're going to use our PowerFlex 525. That's going to be our output or our control variable. And then the encoder feedback on our three-phase motor, that is going to be our process variable. So we're going to need to scale both of those, and we're actually going to control both of those over Ethernet. So we do have quite a bit of prep to do here. So we're going to go ahead and start with Connected Components Workbench. There's a long, awkward silence. Michael is in the room telling me I have a long, awkward silence. So yeah, while we're at this long, awkward silence, why don't you go ahead and hit that subscribe button down there. We put out at least 2 videos a week, and I've been trying to do a live stream a week. I've not quite gotten there yet because I have class. Sometimes we're doing a training class. Also, this week wasn't stellar class. I don't know why I just closed Connected Components. I sat there and did it during the live stream. So, but this week was my favorite class that we do every year. I was over at the high school trying to, show a little bit about what our industry is about. Okay, Connect Components is open, so now we're going to hit new, and I'm just going to call this my PID prep and create. And then we're going to go into controllers, Micro850, and then an L50E, and I have a 2080 L50E 24 QBB. We're going to select it and add to project. And then most importantly, before you do anything else, because I've had 2 of you contact me this week about this, is click on Ethernet here. And instead of obtaining IP address automatically via DHCP, I really wish this wasn't the default option, or they at least prompt you here. We want to configure an IP address. And your default trainer IP address is 192.168.1.10. And then we just hit the tab key, and that would fill in the 255.255.255.0 subnet. Now, this trainer right here is actually on 192.168.20.101. So I'm going to put that in. And then we need to add our Ethernet modules. Now, if you have the 2080 LC50, I'm sorry, not LC50, if you have an L50E, then you have a little indented area here called modules. And this is what we're going to use in this one. We haven't done any videos really with the PowerFlex doing it this way. For all of our other videos, we've been using the user-defined function block that works with all of them. But this is a special area just for the Micro850s that have an E on them. So I'm going to click the add, and on my device type, we're going to select the PowerFlex 525 EE-NET. So I'm going to select it, and I'm just going to call this my drive, and its IP address is 192.168.20.102. Now, the default IP address here on your trainer is 1.12. In fact, I should have entered that first. So yeah, if you're doing this on your PLC trainer, it's 1.12 like that. And this one is that. And by default, keying is disabled. And so since keying is disabled, we don't have to actually enter a major or minor revision here. We're just going to leave it all at the default. So go ahead and click OK. And then we're going to add another module because we need to add our IO link module. Now, our IO link is a generic module, and I'm just going to call it our IO link. And for the generic modules, we need to know some information about it. And one thing I really love about this Turk is how intuitive it is to figure out. So I'm just going to go to my start menu, and I'm going to open up Microsoft Edge. And I'm going to enter the IP address of the IO link module. And your default IP address is 192.168.1.15. Now, this one is actually on 20.105. So I'm going to go there. And then I am going to go ahead and log in. Actually, I don't know that you need to log in to see this. Let's just try it without logging in. So what I'm doing is I'm going over here to the documentation, and I'm going to the Ethernet IP memory map. And okay, you don't need to log in to actually get here. And right at the top here, we have our instance size for our input and our output. And this is the data you need. So we're going to go back over here. And, before we do anything, we have to understand the COM format, though, because you do have to select what format do you want this in. Now, I'm going to leave this as much of the default as possible, just so that we can learn how to navigate the way it would be out of the box. And so it says size in words. That means 16-bit or an INT in connected components. So the first thing we want to do is drop down here and select INT. And then we're just going to fill in those assembly instances and sizes that we see over here. So 103, 103, 104, and 67. Over here, 103, 103, 104, 67. Okay, now we have a ton more to do, but, we have a ton more to do. We're getting ready to have a learning opportunity. I didn't enter the IP address. That is, for your trainer, it's going to be 192.168.1.15. The Micro820 trainer in the training center is 20.105. So I'm going to click OK on that. And then now, as I was going to say, we have a lot more to do, but let's download this and just talk about a few issues that you could have and how to see them and catch them before we're staring at data trying to figure out why it's not working. So I'm going to go ahead and download this program. And yeah, if you need any help downloading your program, or if you're like, whoa, you're just going way too fast through a lot of this, we have a whole course on Connected Components Workbench. And I don't believe it's down there right now, but when this live stream is, oh, maybe it is down there. Yes, it is. There's a link down there that will take you to that course. And yeah, we are in the top chapter, which right now is called the Fast Track to Learning PLCs. Probably won't be called that, hopefully, much longer because this is more than that now. Let's see. Max Planck. What is PID? Well, PID stands for Proportional Integral Derivative. And it is a very common process control method when we're trying to attain a value. And the furnace example is probably the easiest one. So we got a furnace and we need it to be 350 degrees. And so the furnace is sitting here idle, maybe it's 70 degrees. We could light a fire in the burner and we could turn the valve wide open and that furnace would shoot up and obviously it would overshoot and then we would have to manually move the valve back and forth. So what crudely what a PID does is it looks, first of all, how much error there is there and it adjusts accordingly. No, its goal though is one, not to overshoot. As it approaches it, it's going to need to do some slowing down. And then we may have some errors where it can't quite get there. We're going to need to do some corrections over time. And so the combination of the P, I, and D kind of work all those things out. And I did a series earlier where I kind of explained exactly what P, I, and D did. And honestly, I didn't like the way I guess people interpret it because what it made us do was start coming up with all these rules of, oh yeah, well, the P stands for past and the I stands for present and the D stands for future. I'm like, nah, it really doesn't. It really is just some math. But yeah, I don't want to get too far into that. What we're going to do in this series is we're really just going to talk through how to set it up. The next video will be, how do you figure out your sample rate and how do you do the auto tune? And that'll get, ooh, we have a learning opportunity over here. And that will get you through most of it. Okay, so, since we're on a live stream, we might as well learn this together and find out. I may have messed up here, but this is the ultimate prompt that we have to read. And yeah, I did. I had two schools call me this week about this thing right here. So it says download of current Ethernet settings will result in disconnection from controller. Continue with downloading of Ethernet settings. Now, either I entered the IP address into the PLC configuration earlier wrong, or maybe there was a gateway assigned to this. So I'm actually, yeah, this may be turned into how to recover from your Ethernet address if you mess up, because I'm going to click yes. Now, if you get this, you should hit no and go check out your IP settings, but we're going to click yes. And it does say we're disconnected, which it said it would. So now we're going to try to connect to it. And judging by how long it's taken, I probably should have hit the no button and gone and figured out what, oh no, okay. All right, well, no, I just wasn't quite patient enough there. Okay, so let's go figure out what was wrong. So what we want to do now is I'm going to double click on the Micro850 over here. And then, oh, we already have it open. And I'm going to click back on Ethernet. And there's the IP address. And we're saying, I'm not sure why I got that prompt. So let me close this and open it back up just for insanity purposes. Okay, well, let's go and put it in run mode. Yeah, it's interesting. I don't know exactly why I got that prompt because now it says everything is perfectly fine. Okay, well, let's get back to where we were. So now let's go into modules. And what we want to look for here is that they are running. So I'm going to pop the cover off the PowerFlex and unplug its Ethernet cable. And now let's say in code 203, and this will be the most common one you get, connection timed out. And that means chances are that you entered the wrong IP address here. Also on this one, you could get something like connection point invalid. That would mean that you entered either the wrong assembly instance and size, or probably more commonly, can I double click on this while we're live? Yeah. More commonly, this defaults to dent and you forgot to switch it to int. So it's probably one of those things. But we look good. I'm going to plug the PowerFlex back in. And then let's talk about the drive control. So first, what we're going to do is, depending on where you're at, and honestly where I've been with this, I'm going to reset this PowerFlex 525, the main operating parameters to it, back to its default. So I am going to get the B flashing. I know it looks like a 6, but that's a B. And I'm going to hit the up arrow. That's going to take me to the P's. And I'm going to hit the enter key. That takes us into it. And we're going to go to P53. And I'm going to set P53 to 1. And don't worry, when you do this, you're going to get an error. It's perfectly fine. I got an F048 error there. I'm just going to hit the red button, get us back where we were. And mainly now I can hit the green button on the front of the drive. And it starts. And the dial on the front of the drive is actually controlling the speed. Okay, so now let's look and see what we have in here. So even, and I know a lot of people are like, well, you didn't put a program in it, Tim. Well, sure I did. I just downloaded this. This is a program. Now, yeah, we have the ladder and structured text and function block programs, but we can learn a lot before we ever even add any of that. We're going to open our global variables. And then we're going to go down and find, oops, I went the wrong way. We're going to go up and find our drive. So here's our drive, and it has outputs. And one of them is really obvious. That is your commanded frequency. And if we hit the arrow by the logic command, very nicely, Rockwell has put in description for us. So this tells us how we're going to start, stop, and all that fun stuff. So go ahead, and no, it won't work, so don't worry that it doesn't work. Just so we see, we're going to try to put a 1 into the start, and nothing happens. And the reason for that is I've factory defaulted this to make it where it runs locally. So P46 and P47 are the two parameters that you'll almost always need to change in the PowerFlex 525. And so I'm going to go to P46. So I'm going to hit the select key. The B is flashing. I'm going to hit the up key to go to the P's. And now I'm going to go down to P46. And 1 means operate off these buttons. We're going to take it to 5. That means operate off of Ethernet. And now, if we go over here and we check the box, my motor does start. And right now, though, the speed command is still coming over our little dial here. And if we go and look into our drive :I, we're actually getting feedback on what our output frequency is, and we get some drive status bits, and we can see what they are right here. We got some check boxes by some of them, such as ready, active, and yeah, command direction and things like that. All right, now uncheck the start and notice it does not stop. And that's because you also have a stop bit, and that gets us stopped. So we have to put a 1 in the start to make it start. We have to put a 1 in the stop to make it stop. All right, that's enough that let's go ahead and make ourselves a little, well, yeah, we should make an HOA for this. So we're going to go ahead and disconnect. And yeah, we're ready to create a program now. So let's right click programs, add, and we're going to actually, I think we're going to do some of this in ladder and some of this in structured text. Let's start with ladder and double click on prog 1. And one thing I did for this, this is the video trainer, but actually I work all the way across because we have the getting started wiring, and that gets us input 4, input 5, input 6, input 7, input 8, switch 4. If you work your way across, I'm going to use switch 4, and that is going to be wired to 12 and 13. Now that is not in your getting started guide, so you are going to need to add these. And if you're not sure about that, go back and look at the getting started video. But we have those already wired. So I'm going to go to my global variables, and their tags are going to be IO, EM, DI 12. That's going to be hand. And then IO, EM, DI 13, I'm going to make auto. And we'll probably need them more in the next video, but that'll also give us a spot where we can run this motor without going and toggling bits. So now we'll go into Prog 1, and let's bring a go look for a 1 down. And since we just entered those aliases, I don't need to know that now. I can just type hand, and that's going to fill it in for me. And you notice how this hand is just way crowded right here. You can adjust that. Now you have to be really careful adjusting that. I kind of wish they would add an auto sizing feature to connecting components. But if you will click over here in the white space to the right of your rung, actually going to bring up the ladder container properties over here. And you have a height. So we have element or cell height. And right now it's at 25. And if I make that 30, that'll space that out a little bit. Now it spaces everything out though, so you can get really tall in here if you get carried away. But yeah, 30/30 seems really nice. So then we're gonna bring an output energize down, and we're gonna go find drive :O dot, and we have our logic. Whoops, didn't go far enough. .1, that is our start command. Okay, now we have this reverse coil, and this is not available in all languages, but what this would do is if this rung was false, it would turn it on. Now I kind of go for the more super universal instructions. So what I'm going to do is I'm going to bring another rung down, and I'm going to use an output energize, and we're going to go for the stop, and we'll just copy this because the exact same thing with a 0 at it. That is stop. Okay, now see how we're truncated here? Got some dots in the middle. That's the same thing. So we click here and we go up. We can make our cell width 35. Oops, still a little narrow. The words are a little long there. There we go. Well, that's still, yeah. Yeah, let's go and go for the, there we go. We go big here. So the question then is, and this is a fun question in the class all the time, is what should we put here on the left side of the start? And usually everybody thinks, well, yeah, I need to put a go look for a 1 for this hand. And I'm always like, well, aren't we probably getting ready to add auto? And they're like, yeah. So they'll bring another one of these down and be like, yeah, we're going to go look for a 0 in auto and a 0 for hand. And I'm like, well, I don't know how many systems you've looked at, but I thought when you're in auto, the thing could turn on and off at any time. And, usually they're like, oh, okay. And so what I always ask them, I should put an alias on that. That's all right. You should go back and put something on this. I'm not going to this because we're going to mainly just use this to toggle it. But what I ask them after that is, okay, when do we want the motor to stop? And they usually gravitate back to this, but you actually want the motor to stop whenever it's not starting. So literally, we're going to copy this and we're going to paste it right there. All right, let's go ahead and download that and just make sure it works. But yeah, I gotta admit, so this is the first 5 o'clock stream I think I've ever done. Y'all are much quieter in the 5 o'clock chat than we'll say the 1 p.m. chat. 1 p.m. the chat's blowing up. All we got is Max and Brandon and Michael now to hold us through during the download times. And what? Oh, well, no, it looks good there. All right. Now, every time you download, once you have a controlled area Ethernet, you're going to get error 73. That's just because you took it offline, and all you got to do is hit the red button. It's ready to go again. Okay, so now if we switch forward to the left, give a little zoom here, then we should see, and we do. Let me escape this where you can see. And so, yeah, we got speed. Now we're still controlling speed here. That gives us a convenient place where we can run this motor now, though. All right, so now what we want to do is we're going to go ahead and disconnect. And next, actually, I said that, and no, we need to see that first. Let's reconnect. Sorry about that. And now we want to get our speed. Hey, Brad, how you been? And Jeremiah. Oh, you're just listening, Jeremiah? Well, hopefully it's good stuff. Okay, so now what we want to do, we have the start stop going over Ethernet. We want to change our speed now over to Ethernet. So let's go ahead and hit the select key in the middle. That'll get the B flashing. We're going to hit the up arrow. That'll get the P flashing. And we're going to hit the enter key. That's going to get our number inside the P and find 47. And we want to take 47 to 15. That means Ethernet control. And now be incredibly, as in, oh man, really big here. I forgot if I had to zoom on. Be incredibly careful because default, the speed is 0. So if we try to start this, you may hear that little high pitched noise. I can hardly hear it. But if you run this at 0 speed, it still is applying voltage, and then you're applying heat when you apply voltage. And that fan will not cool itself if those blades are not turning. So now what we want to do is we want to go find that tag. So let's go back to our global variables. And actually, we could go global variables. We also have drive colon logic here. So we could right click here and go to variable monitoring. That'll get us really close to where it is because yeah, it's the frequency command here. And I always ask people in class, well, go figure out how to operate that. And I'll tell them, give me 30 hertz on it. And usually we enter 30 in. And so then I always tell them, pay attention to the display when you do it. So if we switch forward to the left, we're getting 0.3. And so we need to multiply that by 100. So if you want 30 hertz, we're going to need to put 3,000 there. And now, if we switch forward to the left, it will come up to 30 hertz. Okay, now I don't want to work in 0 to 6,000 range, and I don't think anybody does. And it's terrifying the systems I see that are working in some crazy numbers like that. So what I want to do is I want to make our motor speed based on percent. And so now we will hit the disconnect button. Let's see, Tony, I haven't worked with CCW. Are you not able to do online edits with it? Well, a couple things on that, Tony. So first, yes, you probably saw it while I was online. We have a run mode change button, but that only works in Developer Edition, and I try to stick with only what the free version offers, since there is a free version of connected components. So yeah, I could have made a run mode change, and I'll have to say it's not very fast. It's not like Studio, but I would say 90% of the people are using the free version that are watching this video, maybe even more. So I'm going to go offline every time on this. All right, so now we're going to bring on down a new rung, and we're going to bring down this instruction block here. Now, we could actually go find stuff, but I almost never use these tabs. This is a really cool feature they have. Is I can just drag down an instruction block. I can double click on it. And then as long as I know what I'm looking for, I can just type it up here. And we're going to find an SCL. That is the scale instruction. We're going to double click on it. And so our input is what speed do we want to tell in 0 to 100%? We don't have that yet. So I'm going to put in our speed command. And notice you got a little yellow triangle in there after you just type those words, and that's because you just typed words. It doesn't know what it is. And in this case, all you got to do is double click either on that triangle or anywhere in this bottom section, and that'll prompt you. And most of the time it knows what data type you want. So I do want a real number because I want to be able to enter a decimal in. So I'm going to click OK. And then we have in raw max, in raw min. So this is the range that I want the speed command to be. And so I do want 0.0 and I do want 100.0. And then we have the EU min and max. See, that's the engineering units. And you know, and Rockwell, I still disagree with you on this one. This is not the NEU max and NEU min. This is what we're getting out of it. But it's the same way in studio, so I guess I'm wrong. But so our output units are the engineering units. So I want 6,000. That's going to be 60 hertz. And our min will be 0. Okay, now this is the very important one right here to think about, is this limiting. If you make limiting false, then it will scale past 6,000 or past 0. So we could end up with 6,500 or 665 hertz, or we could end up with a negative hertz. Now, I don't want to do that. I want to keep them in range. So on the limiting, I'm going to just type the word true. I didn't have to create true. This, if you mouse over it, it was looking for a Boolean tag. And so I can just type the word true and it's done. All right, now the next thing we have is our output. And so that is, where do you want to put it? Now, what I'm getting ready to do will not work, but it's always a good lesson, is you think you want to go here and we want to go find that drive :O, dot, and we want the frequency command. And we have a little yellow triangle here though. Mismatch between assigned expression type int and target data type real. So this is going to put a real number out. This is an INT, an int or a 16-bit int. And so here's where we need the any-to instructions that we learned about in the analog exercise. So we're going to drag down an instruction block and double click on it, and you can just start typing any, and that's going to bring up all these any instructions. And this is an easy way to convert data from one to another. And we needed our drive :O dot frequency command. It needs to be an int, so we're just going to take any to int. And so this, we'll right click and we'll just cut that out, and we'll right click and paste it here. Okay, so now, whoops, I don't know how I ended up with that, but that was bad. Could have been bad, but all right. So I'm just going to call this my speed command scaled. And then I'm going to double click in the bottom here, and that's going to bring it up as a real. And all we got to do is hit OK. And now I'll right click and copy that. And up here, I'll right click and paste that. And then let's go and hit the build button, just in case I did something crazy there. I don't think I did, but honestly, about 10% of the time I still get this wrong. So we're going to hit the build button. And it says build, oops, build started. Hopefully I think it said no errors there for a second, but maybe that was all right. So yes, build succeeded, no errors. We're good to go. So let's go ahead and download that. And yeah, Tony, so developer edition, actually everybody on here's not just Tony. I don't use the online edits in Connecting Components much because they are slower, much slower than what you do in Studio 5000. But that doesn't mean I don't feel you should get Developer Edition. And the main reason is Developer Edition comes with 8 to 5 support from Rockwell. And so it doesn't take many times of, something holding you up or, you getting stumped on something to pay for the 8 to 5 support that developer gives you if you're learning Connected Components. All right, so now we should be able to put a speed command in. In fact, I probably should have put a speed command in just so I didn't end up accidentally run this. So I'm going to put in 25. Now that will be 25%, and 25% of 60 is 1500 hertz, or 15 hertz, and that's why we see the 1500 there. And now, if we switch for to the left, whoops, get that back where it was, then we're running 15 hertz. So that gets us through our input scaling. I mean, our output scaling, actually. That gets us through our drive speed scaling. Now, there's a lot more involved in the IO-Link scaling because, well, we do have a video series on IO-Link, but it's not in this fast track series, so we need to slow down a little bit and talk through some things and make some observations. So if we go over here and go ahead, close this out, and double click on our global variables, and we hit the arrow by IO-Link:I, well, we have a lot of them here, and I had to do a lot of scrolling, and anybody who's been in class knows how I feel about scrolling. So I want to know, where is this encoder at in this? And here's where I just can't say how good of a job Turk really has done in their documentation built into this module. Is if we scroll down, we're still on the documentation Ethernet IP. If you scroll a little bit, here's all the mapping for this. So our encoder is wired to channel 3, and that means somewhere around 50, we should have some data that we should be able to see changing as this motor rotates. So if I go down to 50, there's no doubt I have some numbers here. And if I switch my switch, those numbers are definitely changing. Outstanding. Okay, now we've got to take these numbers and turn them into something though. And we got a couple of ways we can do this. Is first of all, I went ahead and got the excerpt out. That'll help you a lot. Is if we look at here is how that process data is mapped. So in one of those cells, we have the multi-turn count, but notice we also have a couple of warnings along with that multi-turn count. And then we have the multi-turn position. Now, let's look at the multi-turn position first. So, oops. So the multi-turn position, first of all, let's take and just rotate the fan just a little bit and see which one's actually changing here. All right, and we see that top one is the one that's drastically changing. So that is our position on this particular rotation. Now, if we go back to the Turk webpage and go to main, we can also read the data here. So if I click on input and go to channel 3, well, you see I got some funky data here. And then it's like, okay, how do I line this funky data up with that funky data? Well, I need some real known. So we're going to click on this IIOD. I struggle with this acronym. IODD configurator. And now we need to log in. So we're going to log into this. And then we're going to go to port 4. Actually, I'm going to unlink this thing just so we can be like we were. There we go. So this is what it looks like out of the box. So we got port 4. We got some process data. And now if I rotate this, we see that funky stuff changing. So in order to get this into something we can interpret, we need this IODD file. And so I've gone ahead and downloaded this. Now, one really cool button is you have the web search button here. That I have not found a time that hasn't worked on a really common device yet. I've seen a few odd devices it doesn't work on, but it does a good job. But also, you can download it right off the internet. And I already went ahead and downloaded this. And I'm going to select the IODD file and click open. And mainly that turns it into where we can see the actual process data. So mostly we have a position, and right now our position is 36,279. And if we go over here, neither of these numbers are 36,279. And this can get super duper confusing. Now, in the longer IO link version of this video, I kind of go into the weeds of why this is happening. But the main thing is how connected components treats this negative sign compared to what this is actually doing. So if you have a 16-bit integer, connected components, it's got it as an INT, and the range of an INT is a negative 32,768 to a positive 32,767. Well, this is expecting an unsigned number, so it wants to go from 0 to 65,535. All right, so I don't want to get too far in the weeds of that. What I want to do is just talk us through how to fix it and then see what difference it makes. So all we're going to do is we're going to disconnect. And in the longer video, I have a more elegant way to do this, but honestly, I kind of think this is still the better way. Is what I want to do is I'm going to bring a new rung down, and we're going to go look for a 1 down, and I'm going to call the, oh, and I'm not calling this anything, I'm going finding it. This is IOLink :I bracket 50.0, because that was the first number. And then we're going to bring this down, and I am going to call this my, oh, what am I going to call it? I'm just going to call it, because I can't think right now, position underscore DINT. And then I'm going to double click down here. Now be careful, right here, notice it wants to make it a Boolean tag, which arguably is right, but I want this to be a DINT. So we are going to select a whoops, not a derivative, a DINT. There we go. And what we're going to do with this, now we're going to go ahead and select .0. And now all we're going to do is we're going to right click and we're going to copy this rung. I'm going to paste it 15 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And the main thing to understand here is bit 15 of an INT, which is what this actually is. Whoops, where do I have it? Oh, I don't have it here, but is the sign bit. Now, if we move this bit by bit over, then that sign bit will be in bit 31, and that's going to make those numbers line up. Now, a lot of you are probably like, well, can't we use like the mask move and do this in one fell swoop? Well, in the other video, we talk about the mask move does not work, or it does not exist in connected components workbench, nor does the swap byte command, nor does the bit distribute. So I did make something to kind of crudely do this. And I urge somebody else to go ahead and finish it up and put it in Rockwell sample downloads. But right now, there's not a lot to binarily work through data. So all I'm doing is I'm going to increment each one of these, both sides, make sure we don't skip any, because I probably will skip one anyway. Somebody throw in the chat, they see me mess up. But we're just moving this straight over. We're going to increment all the way. We should land on 15 when I'm done here. So 6. Whoops. Yeah, play. How many typos can I make here? Yeah, there should be a faster way, but until somebody teaches me it, this, arguably I made a slightly faster way, but I think this probably is the cleaner way to understand. Yeah? Yep. All right, Michael is out, everyone. That means dinner will be soon. I won't be getting, my food's gonna get cold. Save me some food, man. All right, 5 more to go. So I probably could have just scrolled and found these faster and typed them in. Let's see. Oh yeah, why didn't I do that? Y'all sitting here like, man, this guy doesn't know how to use the scroll wheel. There we go. Oh, now I'm picking up speed. I'm right here at the end, but I'm getting it now. Whoops. Well, apparently that's not very accurate for me though. 13, 13, and then 14, 14. Whoops. And finally 15. goes to 15. Okay, now just so we can understand what this actually did, right above this, we're going to add another rung, and we're going to bring down an instruction block and double click on it, and we're just going to grab an equals, and we're going to put IO link colon I bracket 50 bracket, and that equals 0, and then bring down another instruction block, double click on it also, and let's bring down another equals, and what did I name that? Position dent. And so now we'll look at position dent to be equal to 0, and then bring another instruction block down, and we're going to type in OP, and that is a no operation. So all I've done is made this where you can easily look at these two values, and let's go ahead and download that. And, kind of going back to what you're saying too, maybe I'll show one with online edits, but honestly, I don't know. Yeah, I'm not real happy with the online edits and connected components workbench, but yeah, it was right. See here, the run mode change button. If you hit it, and then you kind of have the accept, test, and assemble button after that. Okay, so now, oops, not quite done yet. So now notice negative 29,257, but this is saying 36,279. But if we go over here, 36,279. So by getting rid of that sign, which really all I did was make this a 32-bit number, that way the sign bit would be down on bit 31. That gets these two worked out. Now that's the easy one. The other one's a little more difficult. So if we go back over here, notice the data is not perfectly lined up in this case because we actually have 3 diagnostic bits in 0, 1, and 2, and then 3 through 15 are multi-turn count. So what we need to do is take bit 3 of the other number and put it into bit 0 of some new thing. So let's go ahead and see, am I going to do this? Oh, no, Tony, I'm not going to do this online. I am going to click on it so you can see it. If I click the run mode change button, then we would get something like this. And once you make a change, then you'd have test changes, accept changes, or you could discharge. Now I'm just going to turn that back off and disconnect. And yeah, we're going to go down here and let's just copy that bottom rung to get us started. So we're going to copy and we'll paste it in the same spot. And in this case, we want IO link 51 because that's where that multi-term position was. But we want number 3 because that's the first bit because those first 3 you have some diagnostics in them. And then we want to put this into, let's call this our turn, DINT. And then we'll double click down here. And I am going to make this a dent, a DINT. And then we'll click into it and we are going to grab .0. All right, this one takes a lot more precision because notice 3 is going into 0. We're going to increment all the way down. But mainly we want to copy this rung. And now we're going to paste it. So this will be 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so now we can go up here. Whoops, nope. Get ready to scroll up and change all the rest of them. So now we're going to grab 4. In fact, I'm going to work down the left side first. 4, 5, 6, 7, 8, whoops, 9, 10, 11, 12, 13. Uh-oh. Why am I one short? I messed up somewhere. Did somebody see where I messed up at? It's something wrong. 3. Up. There it is. Oh, man, right at the beginning. That's all right. We'll drag this one down. Oh, come on. Let my drag work. Oh, there we go. And then we'll make this one 15. I'll get one chance to do that. After that, other side of there are going to be wrong. Okay, so then on this side, we're going to increment the number. So we're starting at 0. This one we're going to grab 1. This one we're going to grab 2. This one we're going to grab 3. This one we're going to grab 4. This one we're going to grab 5. This one we're going to grab 6, 7, 8, 9, 10, 11. This should have been a 12th one, I think. Yeah, oh, I got another wrong. There we go, 12. Okay. All right, now let's download that and see what it does. I have to say, I mean, well, hopefully it turns out good. But yeah, y'all are a quiet group in the evening. First, it's kind of nice to be mellow group, maybe. Well, hi, Mom. There you go. My mom's in the chat now. There we go. All right, so we download that with project values, which means we have to clear that out again. And clear that out also. Hey there. Okay, so now if we look over here, oh, we didn't, oops, I did not put that in here. Next time we'll put that in there. But for this time, we're going to right click the position dent and variable monitoring and its value. Oops, that's the dent. We want the turn. The turn is at 44.75. And if we click over here, 44.75. Okay, so now this is what we want to do is we want to convert this into the multi-turn position. Your count, that is the whole number. The position is the decimal. So if I could slowly get this, let me see how lucky I can get. I'm not going to try really hard, but if I can get, oh, yeah, oh, there we go. So if you notice, if I bump this, if I could get lucky enough to bump it just slightly. All right, we're at almost, there you go. All right, we're not quite getting there. But this number will go up to 65,535. That is the maximum of an unsigned int. And so if you take this number and divide it by 65,535, that'll give you the decimal part. Now, here's the perfect example. I didn't want to do this first part. Oops, where am I going here? I didn't want to do this first part in structured text because you really cringe when I do this, but ultimately this whole thing should be in structured text. And so what I want us to do is we're going to try to walk through this in structured text so that you can start seeing, well, one, how all three languages have advantages. And this one really is the clear one because even here we had the STL, we had to do the any2 int. We're going to do a lot of these any2s and we're going to have a lot of intermediate numbers in here. And if we just write this out in structured text, life's going to be easier. So let's hit disconnect. And let's go right click programs, add structured text. And double click on probe 2. And so we're going to call this our, well, what are we going to call this? Our position. Sounds good. Yeah, apparently I did position dent before, so this will be our position. And then we want to right click position, variable selector. And since we did it just floating in midair, it has no idea what you want to do. So I'm just going to make this a real number because I want that decimal place. So then position, and then we want a colon equals. And that kind of tells it whatever you do over here, put the result right here. And first, let's hit the basics. So we had over here our, oops, our position dent. That was kind of the position around that. So we're going to right click and we're going to copy it. And we'll go over here. And let's paste position dent. And this is not going to work. Don't worry. This is what I want us to walk through this though. Ultimately, we would like to divide that by 65,535, semicolon at the end, which I always forget. And we're going to hit the build button on that. See, Brad, what happens in CCW if you set a dent equal to an int? It will not let you. You're going to run into the exact same issue that we're getting ready to have an error right here on. So that's one thing about CCW. It's insanely picky about its data types. So colon equals must precede a real expression. And since I made the position, since I made the position a real number, everything in here has to be a real number. Well, how do you make 65,535 real? You make it 65,535.0. Now, position dent, if we want to make it real, we're going to have to use those any two instructions. And so I'm going to type any, and we're going to find the any to real. And then we're going to open parentheses, and we're going to put that around that. So that will take care of that. Now, we're not going to download this, but I want to make sure it works, make sure we have no typos. So I'm going to verify that one more time. Well, hello, 1984. Good to have you with us. Need to get Michael to spec me on a faster computer. I need a faster computer, Michael, if you're still out there. Okay, so build succeeded. Yes. Yeah, you could do an any to dent. Now, in this case, now for what we're specific, yeah, that would have worked fine. For this specific case, we need this decimal because whatever this number is divided by 65,535, this is going to be a decimal. In fact, this will never be, oh, let me take that back. If this happens to be 65,535, it'll equal 1. Everything else is a decimal. All right, now that is just the right side of our decimal. We want to put the left side of the decimal in here also. And so the left side of the decimal is turn is the turn dent. So turn dent plus that. Now, similarly, this is a double integer. If we want a real number over here, we got to use a real number over here. So we are going to put the any to, oh, I'm up against that. If you'll leave a space there, it'll fill it in for you. Any to, and we want to grab that real, and then parentheses, turn down, and close parentheses on that. And let's go ahead and download that because, yeah, that is going to hopefully, we didn't actually test it, but I believe that's going to give us our total position. Oh, I didn't. I keep forgetting to put that up where we can see it really easy. That's all right. There's only one value. We're getting ready to go right back offline to do another. Maybe I'll remember it this time. Okay, this time I'm going to double click on my global variables. And we'll just go down and whoops, it's right there. And there's our position, 44.74595. So if if I did everything right, if I'm getting ready to click over here on the edge, we should have 44.74 in the one. And shotgunning, that should be about 34,000 in the other. And so, oops, so I'm a little off on my shotgun, but so yeah, there's the 44.74. That's the number of turns. And that divided by 6553 is going to be that. So now, if I switch one to the left, oh, it doesn't run because I do not have a speed command. So we're going to put the speed command at 25%. And now if we run it, then this number is steadily going up. Okay, now that still is not good enough for our PID. And I think a lot of us get stuck right here because most of your exercises on PIDs are showing an analog in and analog out. Well, in this case, we have an Ethernet out, but we managed to work that one out. But here, we're getting just a continuous measurement, but we need the rate of this thing. How fast is it turning? And so now there's a couple different ways we could do this, and we did a video kind of showing tons of different ways to do sample rates. I'm going to do the most basic sample rate here because, well, I think it's all we need for this. But depending on how this video is going, I may play with some different sample rates at the end of it. So we're going to disconnect. And while it's on my mind, this time I'm going to go over here. And in fact, we don't need this one anymore. I'm going to type position. And, oops, that will still need to be there, but now it needs to be 0.0. And in this one, it doesn't exist yet. We're going to put our speed feedback. And we're getting ready to go figure this one out. So I'm going to double click down the bottom. It does need to be a real. So we're going to type in REAL real. And now we need to go work this out. So honestly, I should know. So we have videos on how to do a sample rate timer in Ladder, and I'm going to go through exactly how to do that. So we're going to bring down a new rung, and I'm going to bring down an output instruction, and we're going to type TON. And typically, now this is one bad habit I see in a lot of your connected components workbench programs is you double click on the TON and you go to town. Now, what you don't realize happened in there is you just created a tag called TON_1. Now, when we're troubleshooting a machine, TON_1 is not going to help us. So we want to double click back on that. And you don't realize, but down here there's an instance. We want to name this something relevant. So I'm going to name this our sample rate. That way we know what it is. And now we're going to put our go look for a 0 in front of it, and it'll be really easy to find our sample rate. Oops. Well, it would have been easy if I spelt it right. Dot Q. The Q bit is the done bit from Studio 5000. And we have videos kind of talking through this. And we're going to make this T number 1S. That means 1 second. That's one thing the connected components got right. We don't need to know milliseconds. We don't need to do calculations of hours. You know, actually, I'm going to change this up. Just in case there's a question and we want to play with the sample rate, I'm going to make this our sample rate, PRE. And I'm going to double click on it. And since it's connected to this, it's going to come up as a time. And in the project value, I'm going to put T number 1S. That's going to download it with that 1 second. And you know, while I'm at it, I should have done that up here. So we don't burn our motor up. I'm going to go in the speed command. That project value, I'm going to put 25, just so it has a number. That way we don't burn anything up. Okay, so that means that this Q bit will be true for 1 scan every 1 second. So now we're going to go back over at our structured text because I still firmly believe that this is a place where structured text works best. Is we're going to use an if statement. So I'm going to put if, and then parentheses, sample rate. Oops. Oh, okay. This is a good learning opportunity. Notice we do not have that sample rate timer. When you create tags like we just did there, they go in as local variables. So if I double click on prog1's local variable, there's my sample rate and there's the SCL because I didn't name it. We're just going to right click, cut that out. We're going to double click on our global variables, go to the bottom, right click, paste. That'll make the global variable, they're accessible anywhere in here. And we can go right back here. And now when we type sample rate, we have sample rate dot Q. So if sample rate Q, then, and in our then we're going to put, did I call that speed feedback? Speed? Yes, there it is. Speed feedback, colon, equals, and now we got to figure out what it equals. So what we're going to do is it equals position, as we have that, minus previous position. Now we don't have that. It doesn't exist. That's why I had to type it out. Now this is a real, so we're going to make this a real also. So right click, previous position, and make its data type a real. And we'll click OK. So every 1 second, we're going to subtract position from the previous position. And we are going to say that previous position, colon, equals position. Then to finish our statement up, we're going to put an end if semicolon. And let's go ahead and hit the verify button because it's, whoops, I hit the download button. Now you got to sit here and watch me awkwardly wait for this to, well, I meant to hit the build button because what I was going to say is it's, oh, well, there you go. It's very easy to make mistakes when you are doing structured text while you're learning. And so, yeah, I have an error anyway. And that's what I was going for was actually this button. That's the build button. It would have told me. So expecting a real data type, variable or constant. Where did I go wrong on that? Oh, speed feedback. Here you go. So here's where connecting components is, that's what I mean by just ridiculously picky. 0 will not work. We need 0.0. There we go. That'll fix that one. But all I wanted to do was hit the build button, not the download button. Anyway, so I'm going to hit it again just so you, let's see what result you should get. All right. And we got no errors. And oops, nope. Now we have no errors. And so we're going to go back to Prog 2. So what this is doing is if sample rate Q, this will be true, 1 scan per second, then speed feedback equals position minus previous position. And then we're moving our current position to the previous position. So this is going to get the amount of change during that 1 second. So that's going to give us revolutions per second. And arguably we could just run it like that, but just to get it kind of in more of what we're used to seeing, I want that in minutes. And to do that, all we're going to do is put times 60.0. All right. Now we need to go back to like 4th grade. I don't even know when it was, but sometime back in probably elementary school, maybe middle school for some of us, we learned about order of operation. And so if we just put this in like this, then it is going to take our previous position times 60, then subtract it from our position. That's not what we want. We want to subtract position from previous position, then multiply that by 60. And so here's where we're going to need some parentheses. That way we get that right. And that should get us there. And this time I did remember to put these up here where we can see them. And yeah, let's go ahead and download that and see how that works. Okay, so now if we go over to Prog 1, oops, then we have a position. Our speed is 0 right now. And our speed command, let me get this out of the way. Our speed command is 25. So since I'm going to actually run this a little longer, I'm going to drop it down. That way the fan doesn't blow all into the mic. I'm going to put it at 10%. And yeah, now if we switch forward to the left, then we are now getting our RPM. And get that out of the way. Now we're capturing our RPM. So that gets us where we can have our speed command out of our PID. That's going to be in percent. And then we're going to get our feedback in RPM. Next one, we will actually go through adding the PID instruction in, piecing it together. More importantly, I know everybody just wants the PID to work, but figuring out our sample rate, figuring out a wind-up issue very specific to Connected Components Workbench, then how to auto-tune it. And yeah, have a great evening.